Example 2, the following information applies to each of 4 scenarios. Assume that a hypothetical company establishes a DB pension plan. The employee has a salary in the coming year of 50,000 and is expected to work for 5 more years before retiring. The assumed discount rate is 6%, and that's noted over here, discount rate 6%. And the assumed annual compensation increase is 4.75%. For simplicity, assume there are no changes in actuarial assumptions. All compensation increases are rewarded on the first day of the service year, and no additional adjustments are made to reflect the possibility that the employee may leave the company at an earlier date. We are making some simplifying assumptions. So let's move forward. This is our high-level description that will apply across the board. The only point I want to make here is at the end of 5 years, this is the final salary. How do we come up with this number? We take the 50,000, and one little factor that you need to be aware of, if this is time 0, this is time 1, the salary is for the year. So we take the 50,000 at the end of the first year, and then if he's retiring at the end of the 5th year, how many years will this compound? This will compound at 4 years. So if you start with 50, compound at 4 years, at what rate? 4.75 or 6? 4.75, you will get this salary of 60,198.56. All right, make sure you do this. Now we are going to look at 4 scenarios, and the 4 scenarios represent 4 different kinds of pension benefit that the company will give out. In scenario 1, the benefit is paid as a lump sum amount upon retirement. The plan will pay a lump sum pension benefit equal to 1.5% of the employee's final salary for each year of service beyond the date of establishment. This is the establishment of the pension plan. The lump sum payment to be paid on retirement is equal to the final salary multiplied by the pension formula multiplied by the years of service. What's our final salary based on what we have seen on the previous slide? That's 6198.56. And then this is saying that the employee will get 1.5% of that. So into 1.5%. And then for every year that he worked 5 years, so we multiply by 5. So essentially what he is going to get at the end then is this number, 4514.89. This is his pension benefit, is this amount. This is what he gets at the end of 5 years. All right, now what we are shown in this table is the following. For year 1, the salary is 50,000. This is what he gets at the end of year 1. The benefit attributed to prior years is 0 because there is no benefit carrying forward. The current year, if we simply take this number and divide by 5, this is called the annual unit credit or benefit per service year. Here we don't do any discounting. We simply take the total amount that he will get at the end. We are saying that he is earning this over 5 years. So every year he gets this much divided by 5. In a strange sort of way, this is like straight line depreciation, where you have a certain amount at the end and you are taking how much does this mean every year. So what's that amount? That amount is 902.98. Now rather than explaining to the employee in terms of present value, future value, to somebody who has absolutely no interest or concern with things like present value and future value, essentially he can be told that every year he is earning 902 for 5 years. So at the end of 5 years, he will get this amount, 4514. Now, this is the undiscounted amount. When we talk about the present value of the future obligation we need to discount. So if you look at the bottom segment over here, the current service cost, the opening obligation is 0. At the beginning of year 1, how much does the company owe the employee? 0, because he is earning the benefit only as he works. At the end of 1 year, how much benefit has he earned? At the end of the year, he has earned 902. But this 902 is going to be paid at the end of 5 years. To report the service cost, we need to take the present value of that 502. So where do you think this number came from? 715.24. This is at the end of year 1. This is the present value of the 902.98 that he would get at the end of year 5. If you discount it back to the end of period 1, you should get 715.24. And I don't know if this reminds you of level 1 quant, the first 2 readings, or the first reading on time value of money, where essentially you have money in the future and you are figuring out present values. This is purely an application of level 1 quant, the first reading on time value of money. So you need to be clear where this 715 is coming from. This is the present value. What happens in year 2? Notice the top segment of this picture is undiscounted numbers. This row over here shows how much is being carried forward from previous years. In year 2, we only have the 902.98 from year 1. And then the second 902 represents the amount that's earned in the current year. But again, this 902 is what will be received at the end of year 5, once the employee has worked for this second year. Hopefully the concept of service cost is becoming clear, because the 902 over here is being earned by the employee when he works for that year. So what's the total benefit earned in terms of undiscounted cash flows? It's 1805.96. What do you think this interest cost means? The interest cost is the interest rate multiplied by the liability at the start of the period. What is the liability at the start of period 2? It's the 715. This is what the company owes the employee. Why are we not taking the 902? Because when we are doing our calculations, we are supposed to take the present value. So the future obligation is 902. The present value at the start of the second year is 715. The interest expense is the interest rate of 6%, which was given on the previous slide. This is the interest rate to use of 6%, given in the question. 6% multiplied by 715 should give you 42.91. And where do you think this number is coming from? This is the present value of 902. And why is this number different from the one we calculated last year? Because this is now being discounted 1 year less. This is at end of year 2, so it's 902.98 discounted only 3 years. All right, I have skipped the remaining years so that I had space to write, but in the curriculum this is all shown for the 5 years. Scenario 2 now. Prior years of service and pension paid as a lump sum upon retirement. The plan will pay a lump sum pension benefit equal to 1.5% of the employee's final salary for each year of service beyond the date of establishment. Does this sound any different from scenario 1? Not yet, it's the same thing. But in addition, at the time the pension plan is established, the employee is given credit for 10 years of prior service with immediate vesting. So this is a very generous company. It is saying that we are beginning a pension plan, and for your last 10 years of service, you are going to get credit immediately. The lump sum payment to be paid upon retirement is the final salary into the benefit formula times year of service, which is this amount. But let's look at the numbers over here. At year 1, when this plan is starting, so at time 0, and then we have period 1, in this scenario, when we are starting over here, start of year 1, which is time 0, the benefit attributed to prior years is already 9029.78. Where is this coming from? The reason this is coming, do you remember this number? This is how much the employee earns every year in undiscounted terms. So now we are saying the employee is getting 10 years worth of credit on day 0. So that's the number from the previous slide, which was 902.98 multiplied by 10, which gives you this number right at time 0. Then for year 1, how much does the employee earn? The same amount. So opening obligation, where's this number coming from? 6747. This is the present value. The present value of the 9029 number. What about this number? This is 6% of what? 6% of the opening liability obligation. And what about the current service cost? This is the same as the previous slide. And then we carry forward the way we did with scenario 1, and the curriculum goes on to give you the numbers for 3, 4, and 5. But as long as you can figure out 1 and 2, the rest are mechanically the same. Moving on to scenario 3, the employee to receive a benefit payment for 20 years, no prior years of service. Now, essentially, the company is saying that on retirement, you will keep getting a pension for 20 years. The simplistic assumption being made here is that the employee will live for 20 years. Obviously, in the real world, there'll have to be some mortality-related assumptions, but here we are saying the employee will live. The estimated annual payment, which will be made at the end of every year, is going to be the estimated final salary into the benefit formula into years of service. So now, where's the 60,198 coming from? This is the final salary. 0.015, this is the formula. This is saying that employee will get 1.5% into 5 number of years. So now the company is being generous and saying that the employee will get 4,514.89 at the end of every year after 5 years, obviously once he retires. And this will happen for how many years? For 20 years. So again, if we do our basic TVM stuff, what do you think we need to calculate? So for 20 years now, he is going to get his payment. Does that sound like an annuity? And do you recall how to calculate the present value of an annuity? Hopefully you can do that. On your calculator, what will you plug in? You will plug in the n is equal to 20 now. Because we are calculating the present value of the annuity at the end of year 5. So you'll plug in N20, what's the payment? The payment is 4514.89. And then what's the interest rate to use? The interest rate is 6%. What's the future value? Future value is 0, and you are going to compute the present value, and that, if you did it right, should be 51785.46. All right, so the curriculum is telling us, so we believe that it is the correct answer. Now that is the present value over at year 5. And then to calculate the annual credit, we do that number divided by 5. Why is that? Yeah, this amount, 51,785, is effectively how much the employee is earning over the 5 years. So in simple terms, every year he is earning this number divided by 5, which is 10,357. Why is this number so much bigger than the 900 number before? It's so much bigger because in this pension plan, the employee is receiving money every year for 20 years. So that's why obviously the present value is much larger. Okay, now let's look at these columns. Prior year benefit attributed to prior year is 0. Why? Because at time 0, this is where the pension is starting. Current year 10,357, where is this number coming from? That's the number we just calculated. Where do you think this number is coming from? This is the present value of the 10,357. Then what happens next year? This present value becomes, this is carried forward as the opening obligation. Where is this coming from? This is 6% of the initial liability. And then again, you have 8696, which is the present value of the future obligation. So same logic as the previous slide. The only addition here was that we have an annuity and we had to figure out the present value of the annuity. Other than that, it's the same. Now, what do you think the fourth scenario will be? Yeah, the fourth scenario is third scenario plus getting credit at time 0 for previous years. So given credit for 10 years of prior service with immediate vesting, the estimated annual payment for each of the 20 years is salary plus the 10 previous years plus 5. So now we have a larger amount. So if you look at these numbers, this is coming for prior years. Where did this number come from? This is the 10,357 that we calculated earlier as the each year component multiplied by 10. So that's the initial amount. Current year, same number as what we just calculated. Where did this come from? So this is the present value. And then what about this number? This is the 6% interest on 77, and 8203 is the present value of this number. So this is almost exactly what we have seen before.